So this is looking at solving cubic and higher degree equations. So we've already looked at the factor theorem, we've already looked at the remainder theorem, and we've looked at solving quadratics. So when it comes to using cubics and higher degree equations, yes, I think up to degree 6 you can plug them into your calculator. But you know, if for any reason your calculator goes wrong, then or the question says using the factor and remainder theorems find, then obviously you need to follow this process, and it is a process. It's very systematic, and if you follow the system, then you'll be fine. So the first thing we're going to do is use factors, find the factors rather using the factor theorem. So we're going to go in, we're going to substitute in values and look at what equals 0 and find the factors. We're then going to practice our long division and divide the factor into the equation. Now obviously if it's a cubic you'll end up with a quadratic. If it's a quartic you'll end up with a cubic. If it's a quintic you'll end up with a quartic, and so on. And you repeat these two stages until you get a quadratic that can be factorised. Or, you know, if you're feeling, you know, you can carry on using the factor theorem, or you can complete the square on it, that's fine. The last thing I will say is that when it says solve, you actually need to give values of x at the end. So there's no point giving, saying, putting it all in a nice factorised form and then going, right, next question. You actually need to give the solutions. Okay. So, here we go. We've got a cubic. Here we got 6x cubed minus 37x squared plus 67x minus 30 equals 0. So the first question you're going to do this is, right, I'm going to use the factor theorem. Think about what numbers are worth putting in there. There is no point putting in 1 or -1, because clearly that's not going to work. Okay, I'll just give you a couple of seconds to have a look at that and think. There's also no point putting in any negative number. And the reason is because if I put in a negative number, that'll become negative, that will stay negative, that will become negative, and that is obviously already negative, so my answer is going to be negative. It can never be 0, so I'm never going to find a factor using the factor theorem with a negative number. So what am I going to start with? Well, I might as well start with 2. I substitute it in, I get 4. So x minus 2 is not going to be a factor. I then look at 3. And I get 0. Fantastic. So I know that x minus 3 is a factor. Now, I hope you can see all of this, because I can't see on my camera whether you can or not. So I'm now going to divide x cubed minus 37x squared plus 67x minus 30 by x minus 3. And that's the process there. I'm just going to check to make sure you can see this. Just double checking. There we go. So I'm just going to divide this through and talk through it, because it's just an extra practice for your dividing. So my first question I ask myself is, what multiplies x to get 6x cubed? My answer, 6x squared. So I then take that and multiply this term by it. So that's going to give me 6x cubed minus 18x squared. Do a subtraction. Well, that goes to nothing, so that's all fine. Minus 37x squared minus 18x squared leaves me with minus 19x squared. Bring down the other two, so I now have my quadratic there. What do I have to multiply x by to get minus 19x squared? Well, it's minus 19x. So I'll put that up there. Multiply minus 19x by that, I get minus 19x squared plus 57x. Do the subtraction, that leaves me with 10x. Bring down the 30. What multiplies to give me 10x? It's 10. Multiply everything here by 10 and I get 0. Now remember, you should get 0. If you don't get 0, that's when you need to worry. So, just turning over the page, hopefully. There we go. We now have our cubic now is x minus 3 times x squared minus 19x plus 10. Now 6x squared minus 19x plus 10 is not obviously factorisable. I'm not sure if that's a word or not. So you have a choice. You can either complete the square or use the formula. I chose to use the formula and I end up with 5 over 2 or 2/3. Remember, you will get two answers unless this term is 0. So my solutions are x equals 3, 5 over 2 and 2/3. If you're being pedantic, you would write them in ascending order, so it would be 2/3, 5 over 2 and 3, but yeah, that's if you're going to be pedantic. So that is solving cubic and higher degree polynomials.